young entrepreneur, a researcher, Mr. Samarth Jain, who is director, Jai Jungle Farmer Producer Company Limited. Mr. Samarth Jain is MTech Nanotechnology from Amity University and presently stationed at Jaspur, Chhattisgarh. He has expertise in plastic to fuel, pyrolysis system, incinerator, waste to energy, solid waste management, natural and sustainable farming, pest management and plant nutrition, organic farming, and several others. Apart from that, as we know, Samarth, he has been instrumental in the time of COVID for development of his Mahua based sanitizer, which is one of the leading examples of a technology indigenously developed. I would welcome Mr. Samarth Jain and would love to hear his presentation. Please, over to you, Samarth, for a presentation on the work being carried out by your organization. Please, over to you, Samarth. Thank you for participation also. You have to unmute yourself. Unmute yourself, Samarth. We cannot hear you. Unmute yourself.
I guess now it's okay.
Yes, now it is okay. It is okay.
Okay. Can you
hear you loud and clear?
Yeah. Okay. Can you see the screen? Is it fine?
Yes, we can see the screen.
Yeah, okay.
We can see the screen. Please carry on.
Okay. So first of all, thank you, Dr. Amit, for giving me an opportunity to speak and present two of my work that I'm doing in Jaspur Nagar, Chhattisgarh. And my warm regards and good afternoon to all the scientists from the DSTA, State Council, and all the presenters. Basically, I'll be talking about the two projects that we are carrying out. One is specifically related to the minor forest produce, that's the Mahua, and second is the induction cremation furnaces. First, let me start with changing. Yeah. Well, about the induction cremation, we all know, the wood is getting scarce day by day, and the fact is, in fact, in our district of Jaspur also, out of 12 months, 3 to 4 months, we need to bring wood for cremation from our nearby Ambikapur district. That's the harsh reality. So, and the alternate for this is the standard electrical resistance based cremation furnaces that we all know. As you can see in the screen, this type of furnace is being used to cremate the body. And it has been widely used, and specifically during the second wave, the government also, promoted this, and many tenders were floated. Few were in Delhi, Agra, and 2 or 3 more places. But as we are working very closely with the heating systems and furnaces since last 10, 12 years, that's my experience. And the team which we work has experience of more than 30 years in the same. So we learned that there are a few major issues with the system that I would like to talk about first. Because when the body is being burned, be it human or animal, there are a lot of acids, bases, and other things that corrode the heating elements, because we are talking about the resistance-based element. Or in the high temperature, they are already vulnerable, and when these type of chemicals, are being they are being more reactive at the temperature of like 700, 800 degrees Celsius. So a few years ago, there was a change in the design system that we should isolate the heating elements. But that results in a breakage of element, because we need to achieve higher temperature that is more than 800 degrees Celsius. And that's for continuously 1 or 2 hours minimum for body to be burned properly. So that was the major issue. Now the second issue was that we need a secondary chamber to burn the gases, because high temperature was not being achieved in the primary chamber itself. It was very difficult to maintain that that degree of temperature in such a large volume. So there was a need of secondary chamber. Then again, that's the scrubber. There was high load because the pollutants were available in very high quantity. Other few things were there. It required larger area. There was a very slow cold start. I mean, like if you go to Russians based systems, it takes somewhere around 24 to even 40 hours. For example, if the system is zero, shut down right now, and if you want to make it available for cremation, it will take anywhere from a day to two, to be at the right state. So what we are proposing now and what we have developed is the cremation furnace based on the induction technology, and that will address all of the above issues that I talked right now. Yeah, so yeah, as you can see in the induction system, what happens in the resistance-based system, the heaters are on the sides. If you can see the mouse pressure, usually heaters are on these sides, and it's being heated so that the temperature in the core area reaches like 800, 900 degrees. And you can see here there is very less insulation also. And this is the steel chamber that we are using, and there is just a coupling of the induction system around it. So what we can sufficiently claim after testings of around 200 plus cremation, you can see this is the latest system that we are being operating at Agra via by Salute Rainbows. This is the induction-based system. Also, the size is very less, and I will give the comparative details in the next slide. So there is very high power saving, minimum pollution. I mean, it will be much easier if we see the comparative data. Yeah. So this is the data that we have achieved after 200 plus human body cremation at test site is located at Sri Kshetra Bajada Committee, Tajgand, Agra, and all of the development work is being done at Salute Rainbows, Agra, and Vedic Vatica, Jashpur. So this is the comparison heating mode. You can see the resistance based system, and here is the induction based system. Yeah, the kilowatt required installed capacity for the kilowatt required is higher, but you can see energy consumption is more than 50%. Like minimum, we used to get around 50 to 60 kilowatt for cremation of per body, and here we are able to achieve that in 50%. Also, time it was a minimum time for resistance-based heating system cremation all over the India is 2 to 3 hours, and ours is safely 1 hour. It's less than 1 hour, but for being on safer side, we are saying that's 1 hour. Again, when we compare the cold start time to reach 800 degrees Celsius for resistance based is 40 to 60 hours, and ours is maximum 3 hours, that too for 1100 degrees Celsius. I mean, when the body start burning, the temperature automatically goes high. So after 800, you can simply put the body, and then it assists in increasing the temperature. Again, for the downtime, that's the most important thing, because if anything goes wrong with the system, and insulation is very good, especially we have to make the system so much insulated that it keeps the heat for longer and longer duration of time. So in case for resistance based system, if it's something is wrong and if you want to make any changes, it would take anywhere between 2 to 3 days, so that the condition is workable inside the furnace. While in our system, it's only for 3 hours. As you can see, there is a very thin layer of insulation, and then there are different gaps, and this is the whole system. I think I do have some images later on. I will share. The most important factor is the costing, because although the technology is very good, very efficient, but the costing is approximate of the same, or you can see even the lesser than the previous resistance-based system that is being used widely. And also about the installation area, minimum area was something around 800 to 1000 square feet. That is the standard all over the India. But we can do that in already 500 square feet. So, I mean, that's a good achievement as far as we think that. Yeah, so this is the main system that is running. You can see there is very less insulation. Also, there are few, just 1 or 2 layers of insulating ceramics, that's all. This is the whole system. It's not very much clear from this side, but yeah, this is our induction furnace, induction motor. This is our control panel. This is the chamber where we put in the body. This is a gate for closing the gate, and you can see only one small pipe for passing off the effluent. Video for loading, but check if you can see. Yeah, this is one of the video. You can see the red hot chamber. Yeah, the glowing chamber that is made of stainless steel, and that assists us a lot, specifically because we can achieve the temperature very easily in like 2 hours or so if we start from zero. So I mean, that's all specifically in the induction cremation system. If anyone has any questions, because I will be just keeping it very short, I would be very happy to answer, or we can, continue in later on. Hello. Okay, so I will switch further. Now coming to the work about the Mahua Sanatizer that got a very hype, specifically in the time of the Corona. Basically, because I'm from a Jashpur region and it's too far away. I mean, the connectivity issues is a lot over here. There are no direct transports from any big cities, no railways, and no airports. So we are kind of, being secluded from the market chain. So there was acute shortage of hand sanitizers, as we all know, specifically because I'm also working as a free consultant with the Department of Forest, and sometimes we also work with the Vandhan Kendra. So we came to know that there is a big issue of sanitizer, specifically for the police and CRPF and medical staff. And also there were very uh, news coming of this sort that there is a skin disease happening, or the cancer is spreading by excessive use of isopropyl alcohol based sanitizers. And we all know, because from Ayurveda, Mahua is widely used to treat the skin diseases, and easily available material that I came across to thought that has alcohol was Mahua, because it's being widely brewed and used by the local communities. So we thought of, developing, giving it a try at a very small lab that we have in our office. Uh, the main challenges, as we discussed, there was no transport material available, no machine spares were also available, or we could, purchase, because all the transports were down. And the best part about developing this sanitizer was that nothing from outside of our local town was used. As you can see, we were able to achieve easily 89-90% of the alcohol in our initial trials. Again, after we were finalizing how the process flow will be there, and how we will, run the system. Another challenge that we faced was most of the labor that we have in our town was, mostly uneducated, or they were from the tribal region. And another main issue was because we were a private company, so getting license was a big issue. I mean, we cannot easily get the extraction license or excise license. Another issue was, I mean, investment was required to build test systems. So, because we were working closely with the DFO sir and the collector sir in our district, so we had an unofficial agreement sort of thing that if it is being developed, and we'll help and we'll take over the system. In the images you can see, all these are, the tribal women. She is filling the first batch of our sanitizer. Now this was the testings and training at our facility. And in the lower corner, the system, it was the first system that we developed. It was of 80-liter capacity. Yeah, so about the whole process, I will, keep it brief, but basically what we do, the stock is fermented, that has Mahua, Ranu, Jaggery, and other indigenous
एक
system.
पेड़ से 150 है हमारा। अरे लेकिन अभी तो बहुत दूर है।
Am I
No, no.
audible? Hello.
Samarth, you are audible, but somebody else is speaking.
Okay,
Just,
okay.
just hold on for
Oh,
a second.
sure.
Mr. Pandey, please switch off. आप अपना वो बंद करें, please. हाँ, चलिए समर्थ, please carry on.
Yeah,
I'm
sure,
sorry
sure,
for
sure.
the disturbance.
So it's fine. So this is basically the flow diagram that we used, and the most good thing about this technology is that nothing is, being wasted. If we even compare with the breweries that they are, distilling the alcohol from grains and everything, there is a lot of wastage. What we have done is we have made use of each and every part of the process. Like you can see from A, there is a feed stock. It's a mixture of gourd, mahua, ranu, and other ranu, because it's used for fermentation, you can call it as a mixture of yeast. Then next step is mixing with the yeast. You can go for crushing and grinding if the system is available. You can see the D2, or you can again just leave it like that. And once it's fermented, we check the system if it's fermented or not. There can be two ways. One is the alcohol meter, how much sugar is converted, we can tell. But because we have to work with the local tribal women, and they don't have access to such meters, and we also didn't have by that time because we had no use earlier. So there is a very common method to check the fermentation of mahua. They just listen to the cracking sound in the pot. If it cracks, it's like put 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 it sounds. And if the cracking is more than like 10 times per minute, then it's not fermented yet. So we keep it for another 1 or 2 days. So after the primary, after it's fermented, I mean from step E, the next step is primary distillation. That is the standard by जो मट्टी के बर्तन से गांव में लोग महुआ दारू बनाते हैं. We kept as it is because we wanted to employ them, and we didn't want to make one more machineries, and that could have costed at 3 or 4 lakhs. There is a video that we will show you the system. Most of us might be familiar with that process. Now what we do after, when it's being fermented, so sorry, yeah, the residue what is left, it can be used for two purposes. One is we use that in a biogas unit, so the heat from the gas again is used for the distillation, and it can be used as a cattle feed because it has a very high amount of protein. We did get it checked from the food laboratories also, the residual after what is being fermented. Now, because after distillation, it's a very crude process, like desi technology it is. So there are different grades of alcohol that we achieve. I mean, the different refinement process of ethanol that we achieve in the system. That ranges anywhere from 20 degrees to highest we were able to achieve was 48 degrees. So we need to enrich that. Like 20 is not enough for sanitizer, 40 is also not enough for sanitizer. So this alcohol enrichment unit, what you see in the process H, was developed specifically by us for this purpose only. We feed in the material. There is a very short video I will share after this slide. So the primary distilled alcohol goes into the enrichment unit, and then it enriches it further. And the what output we receive is from starting from 90 degree, it goes to 80, 75, 70, 60% of alcohol. So we store them in different containers, and then we adjust finally. Suppose if we have to get alcohol of around 70 degrees, so what we'll do is we'll mix 60 and 80 or 60 or 90, and if the alcohol percentage is very less, about around 40 that we are getting out, we again put that back in alcohol enrichment unit. Now the residue left in the alcohol, I mean what the waste is removed from an alcohol enrichment unit, it has around 5 to 10% of ethanol. Although that can be used for making drinkable like RTDs, but because we were using the iron containers and those things, and I mean it was not feasible for us to achieve the license, so we tried to experiment with the plant tonic formulation, and it works very well for plant growth, specifically it assists in flowering. We have applied for the patent. Somehow, for some reason, it was not considered novel, so it was rejected. But we have again applied for review. Some, I mean, auditor from electrical department is reviewing that also. I don't know why they have put it in electrical department, but okay. So normal sanitizer, what US says has 60 to 63% ethanol, but now Government of India has increased it to 80%, and for medical grade it's somewhere around 80 to 95%. So we can easily achieve that using Mahua, and no other input materials are required from any big chemical factories or things like that. Yeah, so this is system where you can see when they are this has the size of around 250 kgs. Finally, we were fermenting around 500 kgs of Mahua per day for making the sanitizer. The final plant that we developed had a capacity of enriching up to 700 liters of Mahua alcohol per day. So what we are seeing is the Mahua is being fermented. Now they will take this to the primary distillation. This is fermented Mahua. along with jaggery and other materials. This is the primary distillation where they use the traditional method. So also the essential oil is being extracted by us using this method only because we didn't had any different setup for that. You can see the you can see this part is empty now. There is a hole where I mean there is a pot in which there is a secondary pot and the pot is empty from behind. So what happens is when you heat the system, the alcohol it evaporates, and when it evaporates, there is another. Let me show you. There is another utensil that has cold water filled in. So when alcohol or any other vapor get in touch with this, it acts as a coolant, cooling agent, and it drops into this pot. It's being used since age old way. There's nothing new, but we try to keep it same way so that we can give employment to maximum people. Yeah, we usually this is how villagers usually check how strong is the alcohol or the mahua they have brewed. If it's blue flame and very little of yellow flame and it burns off completely, the alcohol is good. So that's also, I mean, that's how we kept the system. But before feeding into the machinery, we did check with the alcohol meter. Maybe in this one we can see. Yeah, the material is being transported from the distillation primary distillation hub, and now they are checking how much alcohol it contains. And after this, it's being fed into the tank. This tank has been joined with our larger system of 700 liter capacity. You can see the pipeline. She will be feeding the material in. In this way, I mean, we also were able to minimize, the risk associated with the high temperature furnace and the alcohol that has been kept. So we have, kept the distance as far as possible. This is the loading part now. After, yeah, so Mahua was fed in here, the primary digital system. This is our control panel. So when we start the system, there are heating pads all below the system and also on the corners. So it heats up the system. The best part is that our what you can say the heat loss control efficiency is very high. So even if the system is around 100, 110, you can easily touch the system and you can stand by the side. There is no issue with that. Once it's heated, the vapor flow from these two big pipes you can see. This is the chamber, these two pipes. This is the condensation chamber, which has the water and what you say coolant in it. And here we can see the high degree percentage alcohol coming up. Again, because there was risk, so we put the system in such a way that the alcohol that is being generated is shifted to another room. So this is the whole team that works and I mean wholly operates the system and does the packaging and sell it to the government. Now Chhattisgarh Herbal is I mean the sanitizer is being sold by the trade name of Chhattisgarh Herbal, and they are also the proud member of the Jai Jungle Farmer Producer Company that we have formed very recently, and we are working on various other products like that. So a few achievements, keeping it short, that no chemicals were used, everything natural is used. And yeah, the most innovative part was because every sanitizer you must have seen, they have to use either glycol or glycerin or aloe vera for keeping the hands soft. Because Mahua has I mean, inherent property. So even for skin conditioning, even the alcohol that we obtained from Mahua had something that sort of artificial natural glycol that we don't have to use the softener. Even if we use Mahua sanitizer of that has the degree of around 90 degree. I mean the alcohol content is 90 degree. So that was one of the good thing. Another is there is no wastage. Everything is being used. Our system is so easy that all these women, I mean, only two of them can write and read easily. One is the I mean, the Adhyaksha and other is a Sachiv. Other than that, they can't even write, but they are probably manufacturing this. Till date, this is data of 4 months back. They have achieved a turnover of 60 lakh plus. Yeah, these are some of the images. You can see them working. This is the packaging of our sanitizer. This is the whole team. Yeah, other than this, we also works on a few standard technologies that no innovation is involved, but we are developing for SDGs like these are the completely plastic-based bricks. You can see they are very strong, plastic and sand. The major issue here over the plastic is the recycling center is not available for the thin plastics that we use, like for chips, kurkure, lays, etc. So they are not even being purchased by the middleman traders, जो बिचौलिए होते हैं उनसे. So we have developed this one. There are also tiles, which you can see it's very high strength. And again, the system is so easy that even, many villagers, they can work. And we are trying to integrate this with the Vandhan centers, if possible, or, Gothan cameras. These are a few of the tiles that we used. Yeah, so these are a few of our other products that we are working with SHGs, Vandhan Kendras, and our FPC that we have formed. There are various types of infusion blends of the green tea, or we can say. So I was very interested when Dr. Thakur talked about the marigold. I'm very much interested because we do need to buy and we can increase the farmers' income by a lot. Then you can see there are a few capsules also that we are manufacturing, and all of these products are being manufactured by these tribal women only. So that's all from my side. Thank you for your time.
Thank you so much, Mr. Samarth. You have been one of the torch bearer of indigenous technologies in the state, especially in COVID times. We are well aware of your inputs, and even the state government has appreciated. As a council, we did appreciate that. And thank you for your time as well. On a very brief notice, I personally called you up just 2 days back, and you were ready with the presentation. So it was nice to hear from you, and also from the remote areas like Jashpur, these technologies are coming up. So that is evident that Chhattisgarh is, now at the forefront of, or I can say in the realm of events. So thank you, Samarth. So to further the cause of this program, let me call upon Ms. Razia Sheikh, who is MD Bastar Foods. She has been one of the persons who have made the local food famous